Hello, hi students. Welcome to our YouTube channel, Riya's Classroom Calculations. Hope you are all following my video lectures. In the previous lecture, we have discussed what is system and types of system, thermodynamic equilibrium, and so on. In this video lecture, that is in class 4, we are going to study in the chapter 1, pure substance, properties, process, and its types. Pure substance, properties, process, and its types. Hope you guys will enjoy my video lecture. Please like and share and subscribe my YouTube channel and share with your friends so that they can gain some good knowledge. Now, what is pure substance? A pure substance is a material that has a uniform and fixed chemical composition and chemical aggregation throughout, no matter what phase, that is solid, liquid or gases in it. Here chemical composition means, for example, if you take H2O, that is it has two molecules of hydrogen and one molecules of oxygen. This is a chemical composition. And chemical aggregation means having fixed bond, that is it is having two H2O like that. The key characteristics of this pure substance is, first, same chemical composition throughout, that is even if it exists in different phases like ice, water, steam, it is still H2O only. The chemical formula for ice is H2O and water is H2O and steam is also H2O. Can exist in more than one phase. Phase means it is having three phases, water is having three phases, that is solid, liquid and gases. In solid we call it as a ice, in gas we call it as a steam, and in liquid we call it as a water. A pure substance can be mix of solid, liquid and vapor phases as long as all phases have chemical composition, that is chemical makeup. No mixing of other chemical elements. It must not be the mixture of different substances like air. If air is not a pure substance, because in air we have nitrogen, oxygen, carbon dioxide like this, so it is not a pure substance. Which is air is a mix of nitrogen, oxygen like this, I have told you. It is a pure substance. If we mix all the three, it may call it as a pure substance, because the chemical formula for ice is H2O and water is H2O and steam is also H2O. Examples of pure substance: water, that is H2O, same chemical formula in ice, water and steam. Carbon dioxide, that is CO2, same composition in dry ice or gas form. Dry ice chemical formula is CO2. Oxygen, O2, same composition whether in gas or liquid form. Refrigerant, for example R134A, which is used as a refrigerant in refrigerator and in air conditioning. Common in thermodynamic problems as a pure substance. Example of not a pure substance: I have said earlier, air is not a pure substance because it is a mixture of oxygen, nitrogen and carbon dioxide. Salt water, which is a mixture of different salts like water, salt, different substance, so it is a not a pure substance. Petrol is a mixture of hydrocarbons, that is CH2, C2H6, C3H8. This is methane, ethane, propane, like this. These are all the hydrocarbons, which is a mixture of carbon and hydrogen, so it is not a pure substance. Why pure substance matter in thermodynamics? Why we are studying about pure substance? Because it helps in calculating the properties like temperature, pressure, volume, enthalpy, entropy by using the standard property tables or phase diagrams. Make analysis of phase changes, that is it convert from the liquid to steam, like this. It helps to analyze the phase changes and easier and moderate accurate. What is property of a system in thermodynamics? In thermodynamics, a property of a system is any measurable or observable characteristic of the system that helps describe its condition or state. A property is a macroscopic characteristic of a system, such as pressure, temperature, volume, mass or energy, whose value does not depend how the system reached that state. This is a property of the system. There are different types of properties: intensive property and extensive property. First of all, what is intensive property? Which is independent of size or mass of the system. That is, it does not depends on size or mass of the system. So it is called as an intensive property. Example for this is temperature, pressure, density. What is extensive property? It depends on size or mass of the system. Example, volume, mass, total, all types of energy are extensive property. For example, if we take a plate, for example, if you want to calculate the temperature here, it will show the value something 20 degrees centigrade. If you want to measure the temperature here, it will give 18 degrees centigrade. So after some time we can get the equilibrium temperature. So the entire temperature will be equal to some 15 degrees centigrade, like this. So if you measure the temperature of the entire billet, we will get same temperature. It is not depending on mass or size of the system. So it is a temperature is a intensive property. Like this, pressure and density also. For example, if we divide this, here the mass is different and here the mass is different, and here the volume is different, here the volume is different. So here mass and volume and total energy are the extensive properties which are depends on size or mass of the system. Hope you guys will enjoy. The key characteristics of the different properties are the point function or state function. It will depends on, if you consider the PV diagram here, the properties will depends on this point only. If you are analyzing this point, it does not depends on next point. Properties are independent of past history, that is they are independent of path. For example, if this is a reversible process, if the process is coming inside, it does not depends on how the process is coming, and it does not depends on the past history of this process. It depends on only on the point function. So it is independent of path. Properties are exact differential, that is dq is equal to dq1 to 2 minus dq2 to 1. That is, if the process is reversible, if we go here, if from stage 1 to stage 2, this called it as a exact differential. Properties are macroscopic characteristics of the system. Macroscopic average behavior is considered macroscopic. The ratio of two extensive property is an intensive property. Example, density. The ratio of two extensive property is mass upon volume. The ratio of two extensive property, mass is extensive, volume is extensive. So density is a intensive property. All the specific properties like extensive properties per unit mass is a intensive property. For example, specific volume is volume upon mass. All the specific properties are the intensive properties, like this: specific internal energy, specific entropy, etc. Examples of thermodynamic properties are, there are different types of properties in thermodynamics we will consider. That is temperature, how hot or cold the system is, it will tell us about the temperature. Pressure, force per unit area inside the system. Volume, space occupied by the system. Internal energy, total energy of the molecules in the system. Entropy, measure of disorder of randomness, it will says about the randomness. Enthalpy, total heat content of the system. Density, which is mass per unit volume. These are the different thermodynamic properties. Now, what is state of a system? The state of a system in thermodynamics refer to the condition or situation of the system at a specific moment, fully described by its measurable properties such as pressure, temperature, or volume. For example, for the specific moment, if the process is going from stage 1 to stage 2 and from state 2 to state 1, for if we going here like this, and in the next process it is coming like this. This is the, these points are the states. Here we will calculate, if it is a PV diagram, pressure here, volume, V1, V2, P2, like this. These are the states. What is process? In thermodynamics, a process refers to the path taken by the system as it changes from one stage to another state. Here, this is the, I have said before, these points are the states, and the path which follows the points is called as a process. This is one process, this is a reversible process. There are two types of process: reversible process and irreversible process. First, reversible process. A reversible process is an idealized process that happens infinitely slow, allowing the system to remain in thermodynamic equilibrium at all times. It can be reversed and change its external condition with no net change in system or surroundings. Here, the process is an reversible process is an idealized process, which we will imagine in our day-to-day life. This reversible process is not considered because these processes are to be reversible. The process should be infinitely slow, and of all the thermodynamic, and it will follow the thermodynamic equilibrium. This point is also violates because with no net change in system or surroundings, because if we give some heat it will convert into the work, but due to the friction some amount of heat is lost, so the process should be irreversible. But this reversible process is a idealized process for our easy understanding. The key characteristics of this reversible process are: this process should be infinitely slow, that is quasi static, almost in almost very slow process. System is always in the equilibrium, that is in thermal equilibrium, chemical equilibrium and mechanical equilibrium. No dissipation of energy, that is no friction losses, no turbulence like this. Can be reversed without leaving any effect. If the process should be reversed, then some amount of energy is lost, but in reversible process no effect will be leaving. Ideal and no practical in real life. This is this about I am saying. It is an idealized process which cannot be practical in daily life. Here he is saying the volume is increasing, that is expansion. If this same path will be followed in the reverse manner, then the process will be reversible. Okay, next example for the reversible process is slow compression expansion of an ideal gas, melting or freezing of ice at 0 degrees centigrade under equilibrium condition, slow frictionless piston movement. If we have the friction, then the process will be irreversible. Now second process, that is irreversible process. An irreversible process is a real world process that occurs spontaneously and cannot be exactly reversed. The process which cannot be reversed is a irreversible process. It involves loss of energy due to friction. These are the main keywords: heat transfer, turbulence, etc. It involves loss of energy due to friction, heat transfer, turbulence, etc. And the system is not in the equilibrium. System does not come into the equilibrium during the process. Example of the irreversible process are, if we consider the diagram for this, if we consider this process from A to B, that is some compression or expansion, it does not follow the same path, but it follows the another path. Due to this some amount of heat is lost, so this is the irreversible process. Fast gas expansion into the vacuum, combustion of fuel, real piston movement with friction, heat flow from hot to cold bodies. The key characteristics of this irreversible process are: which happens very quickly, it is not a quasi-static process, system is not in the equilibrium, energy is dissipated, that is heat, sound or friction is lost, cannot be completely reversed, which cannot be reversed. All natural processes are irreversible process. In the earth, all the process which follows irreversible process only. The combined PV diagram showing both reversible and irreversible process. Here the volume is increasing, so it is a reversible expansion. If the same process along with the same path happens, then it is a reversible compression. This is a reversible process which shows on PV diagram. If we consider the irreversible process on PV diagram, first the red line shows expansion from one point to the another point, but due to some heat loss due to the friction or any some heat dissipates, then the process will be move upwards, so here irreversible compression will occur. Due to this some heat is lost, so this process is a irreversible process. Hope you guys will enjoy my video lecture. Please like and subscribe my YouTube channel, that is RCC Riya's Classroom Calculations, and share with your friends so that they can gain some good knowledge. Thank you.